Kirchhoff's voltage law by Bode. Gustav Kirchhoff was a German physicist whom in 1845 utilized the research of George Ohm and extended the work of James Clerk Maxwell to create Kirchhoff's circuit laws. One of these laws is Kirchhoff's second law, also known as Kirchhoff's voltage law. KVL states that to follow the principle of energy conversion, the amount of voltage or potential difference gained by a network must equal the amount of voltage dropped. In summary, the sum of potential differences inside a circuit loop must equal 0. For example, in this circuit, E minus V1 minus V2 minus V3 must equal 0 to obey Kirchhoff's voltage law. Here's an analogy for you. This sushi train works by a certain rule. Any sushi made by the chef must be eaten by the customers based on how hungry they are. So, the sushi equals rate of train times hunger, for example. Scenario 1.
Kirchhoff, I need to talk to you. We lost our records for how much sushi we sold yesterday. We have all the receipts which tell us how hungry they were and flow of sushi. Can you help?
Kirchhoff realizes he can quickly use Ohm's lunch law with the hunger receipts, using flow sushi at 10 amps to see how much sushi Annie, Brian and Carl must have ate, and uses Kirchhoff's sushi law to find E is equal to 200 plus 50 plus 250, which lets him know he sold 500 sushi. Maybe he needs a pay rise. He'll talk to DMM later.
Scenario 2.
Kirchhoff, we have a problem! Brian has an eating disorder, so his family must know exactly how hungry he was before coming in. But he's gone, and all we have is the amount of sushi sold while he was here, the other customers' orders, and the flow of sushi train. Help!
Kirchhoff knows he made 40 sushi that day with a train flow speed of 2 amps. Checking the orders of Annie and Carl using Ohm's lunch rule, he can find how much they had. He then uses Kirchhoff's sushi law to calculate 0 is equal to 40 minus 12 minus 20 minus B, meaning B must equal 8, and divides B by the flow of sushi to find the hunger factor.
Kirchhoff lets Brian's family know how hungry he was. In reality, to relate this with circuits, the sushi is really coming from the power source, with the voltage being the amount of sushi, the flow of the sushi train is the current, and hunger factors are the resistances. The train's circular path is the loop of the circuit. KVL in fact applies to all loops of a network. In conclusion, it is evident that KVL is extremely useful for managing the conservation of energy principles and used to find unknown voltages and their respective resistances. Thank you for watching my KVL presentation.